Good morning, students. Welcome to my YouTube channel. In this video, I will be discussing on what is Euler's totient function and how to find the Euler's totient function phi of n. So Euler's totient function is denoted as phi of n and is defined as the number of positive integers less than n, okay, and relatively prime to n. So let us see a few examples. If you have not understood the definition, so let's solve a small example. So let's find the phi of phi. Okay. So let us find the Euler's totient function phi of phi. So as per the definition, how to find the number of positive integers less than n? This is nothing but n. Okay. So it's defined as the number of positive integers less than n and relatively prime to n. So the values less than n is nothing but less than 5, which are nothing but 1, 2, 3 and 4. And the values that are relatively prime, we call it as the Euler's totient function. For example, see here you can see numbers less than 5 are 1, 2, 3, 4. Then how to find whether it is relative prime or not, whether 1 is relative prime to 5, 2 is relative prime to 5. How to find? It's very simple. There are many ways. One method is to using the GCD function, that is greatest common divisor, GCD of 1, 5. So if GCD of 1, 5, if it gives you 1, then that number is relative prime to 5. So GCD of any number with 5, if it gives you 1, then that number is relative prime to 5. So how to find now GCD of 1, 5? So the more information about how to find the GCD of any two numbers, you can watch my previous videos. However, I will give some idea here. So GCD of 1 to 5, how to find? Just take the divisors of 1, which is nothing but 1. Okay. Now you take the divisors of 5. So which are the divisors of 5? Sorry, multiples of 5? There is 1 and 5. So among these, which are common divisors? So it is 1. Okay. So now the GCD of 1, 5 is nothing but 1. The common factors you need to take. Okay. That's what 1. Now let's go for second one. GCD of 2, 5. 2, 5. So the divisors of 2 are 1 and 2. And for 5 are 1 and 5. Among these, which are common? 1. So that will be your GCD of 2, 5 is 1. Okay. Similarly, you go for GCD of 3, 5, it will be 1 only. GCD of 4, 5, it is 1 only. So if you see, all are having the GCD of 1, 2, 3, 4 to 5 is 1. So therefore, the total numbers which are relative prime to 5 is nothing but 4. So the Euler's totient function phi of 5 is nothing but 4. So in this way, the values that are less than n and those are relative prime to n. So that count we call it as a Euler's totient function. Okay. Hope so understood. So let us see one more example. Find the Euler's totient function phi of 11. So you need to first take all the numbers which are less than 5, that is 1 to 10, 3, 4, 5, 6, 7, 8, 9, 10, and you just see which are all the numbers that are relative to 11. So again do the same thing. GCD of 1, 11, it is 1 only. GCD of 2, 11, it is 11. GCD of 3, 11, it is 1. GCD of 4, 11, it is 1. So if you see, all will have the remainder is 1 only. GCD of 10, 11 is also 1. Just now I told how to find the GCD of two numbers. So if you count, the total one is how much? Here 5 and here 5. So phi of n is nothing but 10. So let's see one more example. Now find the Euler's totient function for 8, phi of 8. So first note down all the positive numbers of 8, less than 8, sorry. That is 1, 2, 3, 4, 5, 6, 7 and 8. Now find GCD of 1, 8, whether they are relative prime or not. Yes, it is 1 only. Okay. Now let us find the GCD of 2, 8. So find the divisors of 2, so multiples of 2, that is 1 and 2. For 8, it is multiples is what? 1, 2 and 4 and also 8. So among these, which are the common divisors, that is 1 and 2. So in this, which is the larger one, that is 2. So GCD of 2, 8 is 2. So it is not satisfying the condition. So it is not a relative prime to 8. So 2 is not a relative prime to 8. Again, GCD of 3, 8, if you do, you will get 1 only. GCD of 4, 8, you will get 4. How? Take the multiples of 4, that is 1 and 4 as well as, okay. Take the multiples of 8, it is 1, 4 and 8. So among this, take the common multiple, that is 1 and 4. Among this, which is bigger, 4. So GCD of 4, 8 is 4. So which is not relative prime. Similarly, do for all the other numbers. GCD of 5, 8 is 1, 6, 8 is 2, 7, 8 is 1. So among these, which are the relative primes? 1, 2, 3 and 4. So now this is Euler's torsion function of 8 is 4. So in this way, you need to find the Euler's torsion function. Hope so you understood the video. Now let us see the assignment question. Now you try to find the Euler's torsion function of 12. Okay, the question will be posted in the description box. You can put your solutions in the comment box. So hope you enjoyed the video. Thanks for watching and subscribe my YouTube channel for more videos. Bye.